Hello friends, welcome to my YouTube channel VLSI Techno. Today I started with NAND gate schematic design and their symbol creation, and after this I will done layout and their physical verification. This time for physical verification I am using Assura, a Cadence tool. Assura is mainly a physical verification tool used in Cadence. There are many different tools Caliber is also verification tool. This belongs to Mentographic. Assura is another verification tool. This is a part of Cadence, and PVS is another tool which are also used for physical verification. It is also part of Cadence. Okay, so in this NAND gate design I am using a Cadence Gpdk file. So this time I am using a 19nm Gpdk file of Cadence. So I am already started Virtuoso. So now create a library name NAND. Here you can make any name. Okay, and this time I am using Gpdk. This is a Cadence Gpdk file. Click on OK. So library is created. Then now create cell view. Cell name NAND. You can make any. Here I am using NAND gate design. So make a name, cell name NAND. You can make any name. Okay. Okay, and I want to share another important point, like Assura installation. If you want to know how to install Assura in your system, you can follow my installation procedure video of Cadence. I provide the link of this installation procedure of Cadence tools in my description of this video. And another important point is provide your rule file location on this file Assura tag.lib. Okay, when you open this one it will show here. So I am already provide this one a link of Assura rule file. When you open this one Assura, this is the Cadence 19nm Gpdk file. When for example this one, here is a file name Assura. So I just give the location of this file. Actually here is the different rule file. This one the DRC rule file. This is the LVS rule file, extraction rule file. So this rule file is given to this location of a Assura tech lib file. Actually there is no need to give the here path. If you want to provide the location of a rule file manually, then there is no need to here give the file location. If you provide the location of this file, you automatically rule file attached to your Assura tool. So no need to manually give the location of every rule file. So that I make this one Assura tech lib file, or if we have already Assura tech lib file, just define this one. This is for Cadence Gpdk 19nm. This is UMC file location of rule file. Okay, now I start this one. Now create symbol. Firstly we create a schematic design of NAND gate. So I make a sorry, I do not select symbol, so that no saying here is select symbol. There is two symbols, symbol 1, symbol 2. You can select any one. Symbol 1 by default, select symbol 1. Okay, this is NAND. we have required PMOS also, so just click on here or press I. You can any option use, just press here P, automatically it come here. So make here. If you want to uh, flip, just click here, okay, and then go to here and flip horizontally. There is two options, freeze horizontally, flip and vertically. So here we move flip horizontally only, okay. Now make the connection complete one, this one. So use wire, this one. Okay, I am there no need to move too much, so I am pausing this video. Okay, schematic is created. Now make a give only pin. So name Y B VDD GND. Okay, so this is the pin, this is A. If you make here, or you can make anywhere, just like by default I am clicking here only. For if you want to VDD, just this one VDD. Okay, already want to rotate, just press R, it will rotate left right here. So okay, now complete this one and bulk connection. Okay, now labeling this one. So for label press L and name A B B. Okay, so this is A, this is A, this is B, and this is B, and this is final output pin. Okay, this is completion of schematic. So this is complete schematic design of NAND gate. Now create their symbol. So for symbol, just go to create, go to here from cell view, click OK. Now which direction you want. So in left direction we click this one, and ground we put on bottom, VDD on top. Okay, click OK. Okay, this is created. So if you want to delete, just delete this one. Okay, this line I want to instance name game, give the name NAND. Okay, if you want to front, change the front, just like change Roman this one, so it look like this. Okay, if you want to drag, just and drag here. Okay, so now create symbol. Now one important thing, just click on here to make a curve arc. So just press here, okay, it is created. Now circle is required. You can make any form of symbol, no need to make a complete Okay, it will not show any error. You can create a symbol in any way, any direction. Okay, just save it. So symbol is created. Okay, why we use create symbol is important when this schematic is used for a sub circuit of any circuit, main circuit. Then we have to require symbol creation. Otherwise, every time we have to use this schematic as a sub circuit of different top module circuit, so that we create symbol. Okay, now we move to create layout design. Okay, just click on layout Excel. If you have a layout L or layout Excel or layout GXL, just click on it. Okay, just okay. Here the name, make any name, and this is layout. So click on OK. Okay, just zoom it. Okay, this is layout Excel. There is many feature of this is layout Excel. Okay, so they have a more advanced than layout L, and layout GXL has a more property or more features than layout Excel. So if you want to use multiplier fingers in your schematic design or even your component, just like mouse has a 5 multiplier or 2 fingers, then layout GXL is very important, a powerful tool to design your layout in simple manner. Otherwise, if you have a layout Excel or layout L, and if you want to design a schematic which has many numbers, just like 10 multipliers, 5 fingers, then layout design is very difficult. So that for a multipliers or finger used schematic, we have used layout GXL. Okay, because layout GXL has many property or many features which help to your layout very simple, make simple and comfortable. Okay, so this time the NAND gate is not a very big circuit or very big layout or very big multipliers are used in here, so we just use layout L or layout Excel. So here I am using layout Excel. Actually I have a layout Excel and a layout GXL license, not layout XL. So it is plus point if you have a layout Excel or layout GXL license. So I am using this one. Okay, now create layout. This one is the select from source. When you click on here, all component are come in a box, but for this time I am using this one. Before doing starting layout, I want to tell some or share some important point. Just here, go to option, click on display and provide here spacing. Okay, why a snap spacing? This is important when you align your component. It will important to alignment is in proper way, otherwise it will show DRC error. So now simple, go to here and click on show alignment markers. Okay, and go to DRT edit and change these things to make your layout design simple. Okay, one important thing I tell to forget, just here I am using Cadence 6.15, not 6.17 or 6.16. This is because Assura does not compatible with your choose 6.17. Actually Assura is some old tools for physical verification according to this scenario. So this time they are using PVS or caliber or different synopsis verification tool like Hercules or ICV. They are also verification tool. Okay, so this is the time we are using 6.0 Cadence 6.15. This is because this supported Assura. And one important thing is here, when click on layout here, this one, it show complete form. Assura has also available RCX, LVS, DRC. When you use Assura Cadence 6.16, then Assura will come, but not complete here. Due to that, if you are using Cadence 6.16, run RX will not present on your this utilities. So that I am using a Cadence 6.15 for complete verification utilities like DRC, LVS, and finally RCX. Okay, so now I start layout design. Click on here and select component. Okay, when click here, it show minimum distance, what distance is required. Okay, when press save, it fit. Okay, we connect different element. This one. Okay, this is the 4 component to almost 2 PMOS of NAND gate. Okay, so using okay, now make alignment so that minimize the DRC error. So firstly we make this one. Okay, and one important thing, after the setting of this one point is come here, just so the when you click on here, just show the minimum distance is required for avoid DRC error. So by using the making this setup, it will help to design layout in without minimize or minimum DRC error or negligible DRC error without DRC error. So just click on here, make alignment. For alignment, just click here, press A, so it automatically come. So it come in same direction. If you want to make this alignment, okay, so alignment is completed. This is alignment. We done alignment. Now create wiring. So this is make directly connection. Okay, no need to move here and there now. Okay, this one is the so also the which connection of this part. Okay, before doing it, we attach here their bulk. Okay, so for actually Cadence provide integrated or detached bulk. So for that we have to go parameters, body type, integrated. If you want to integrate it, just click on here. If you want to detach, actually 3 types here. None. If you want to manually put the bulk, we select none. Otherwise, if you want to integrate bulk, just create on here. Otherwise, detach. So which direction you want to select bulk, just here you select left, right, or which direction. So here I am selecting left, it's show in left direction. Here Okay, if you I put on right, it's show in right direction here. If you want to both direction, just click on here, both, so both direction will show here, but this time I am using on left, is fine. Okay, so left show automatically. So if you want to click here, and click same manner, just click on here, detach, and the right direction. Okay, so it's show in right direction. Okay, here so you can provide attach bulk in same manner. This is for PMOS. So if you want to detach, just click left or right, any direction. Okay, okay, this bulk is created. Okay, now make the connection, complete connection. When click on any, it's automatically show the connection. This is okay, so just okay, and move to here is integrated showing. So this is bulk, and this is another pin which is parallel to this one. So if you want to make the connection this direction or any direction, just connected it, and this is VDD. Okay, the bulk is also connected to this VDD. This is the parallel connection. Okay, this is go to output. Okay, when you look at this one, it's so this one is VDD connected, second is directly connected to output also. So automatically it's so this is the VDD and connection. Okay, so this is not a big deal, so I pause this video for some time to make the layout completely. Okay, so that video should show less, otherwise. Okay, layout design is completed. So make the connection, completing the routing, and now go for DRC. If you want to attach pin here, so you can do, but actually DRC is no connection of your pin or your labeling, so you can do DRC. Okay, so firstly we done check DRC if any show error or not. So make the name any name, just I make the name and directory DRC. Okay, so after attaching this library on Assura underscore tag.lib, it show automatically here. So an Assura tag.lib we can attach two library UMC and Gpdk, so that is showing, otherwise it will not show here. So we can click on here and just click on any antenna density or fill all or defaults, automatically it show the DRC rule file. Okay, so now just click on OK. Okay, okay, so it's showing some error. Okay, so now solve out this error. what is that? Annual, and this is PMOS. Width should be must be 0.6. okay. And this is the in area must be 0.015 pm area should be this one. So if you want to show, just click on here, so automatically show here. It show the error, this one. Okay, so make this area this one. So for that we have select here annual, this one, and make a create a rectangle. Here and here also, so that we neglect the okay. Now save it and run again Assura and DRC and check error will reduce or not. Okay, error is reduce. Click on OK. It shows this one only. First two error is reduced automatically. Just click on it. It show the what is the, it show the this one. Nip area must be 0.15. okay. So what we selected here, it show actually here is the bulk, body bulk, and this side is also body bulk. Okay, both sides showing error, this one. Okay, it show that we have detached, so that it's showing error. So firstly we connect to this one. Go to here and what are you changing? Okay, I am trying to solve out. For that I am just pausing for videos for little more. Okay, we connect the pin also, so that it's a complete thing. So this is A, this is B. So we select both by click on first A and then press shift and click on B, so our two will connect selected. So okay, so this is A automatically show here, so just click here. Okay, and second pin is this one, so we move to in. make this via. So via is via down, so just click right click and select here via down. Actually poly is via down. If you know the sequence, first one is poly, then metal 1, metal 2, metal 3, metal 4, and so on for up to top metal. So this is down, so just click on here and select this one. In same manner, just via down. Okay, so this is pin AB and now pin VDD. Okay, this is VDD. This pin is VDD. When this one actually is coming polyform, so just click on it. And change the property. This is poly, so just select metal 1 row. Okay, so it will come metal 1 row, and ground, last pin is ground, so select ground. In same form, so just click here firstly and change the property to metal 1. Okay, and label this whole thing. So for label, just press L and make the name A B VDD ground. All are metal 1, so select here. If you want to we select anyone. Roman width is 0, 1 is too high, so press just 0.5. Okay, this one A. Ground. Okay, if you want to check this is pin A or not, okay, sorry, this is pin A. Okay, now run DRC, so it show the complete. Okay, it show this one metal area, this one error. Okay, increase this metal area to 3s. Now run again. Okay, now select know the different error, what is different. Okay, so I'm trying to solve it, so for that we just pause this video. Okay, the layout is completed. Actually DRC error due to this body annual and PVL, so sort out this error. So what I do is to sort out this error is just adding this one. We make this one as integrated and this one integrated and also this one integrated, and this is detached. So because when we make integrated, it connected to this output, so this is technically error, technically wrong, because this is a output and this is a bulk, so we cannot connect this both bulk and output. So we make this one a detached. When you want to know, just go to property and show here. So just here parameters, it show detached. Here we integrated is connected to output, so that it show error in LVS. So we make detach, and after detaching we add this one pimp. So we attach this pimp by default, making this one. Okay, so for how to make this one, just click on pimp firstly and go to create and create shape and rectangle and draw this pimp. Okay, after the completion of here, this one, now run DRC. Actually this is a Cadence on Gpdk, and previously I am using a SCL, so there is a little bit different between their bulk and layout. So there is no DRC error. Now move to LVS. So this is DRC clean. Okay, the circuit is, I know this circuit is small, but why it's showing error? Just due to this bulk of this device. So now move to LVS. Okay, make this name and LVS is okay. Here is automatically select this one Gpdk 90 and make default. So automatically it's come here, extract file and compare rule file. Click on OK. Yes. If you want to show log file, it show the log file. Okay, this is done. There is no NVLVS error. This is fine. It show that okay, completely match. Now okay, now move to RCX. Before going to RCX, we have to some change in required in this on Cadence Gpdk file, otherwise show error. So what we have to do, just go to Assura and go to models, aspect ray, and copy all this file. So do not copy this whole file. When we want to compare the file, automatically show here. What I copy the file is in RCX is this one, RCX spice int and this file, otherwise show DRC error. So where is this file? Just this one file is belongs to this file. Okay, so this file is required for RCX extraction, otherwise so always all time this show error in RCX. So firstly do this one. So what you have to do, just copy this one file and paste in Assura file, in Assura RCX file, otherwise it will show error. So this will show error every time. After this, now run RCX, otherwise you face every time error. Now run RCX. Okay, this one firstly automatically select this one model aspect ray. Okay, infinite, just coupling, decoupling, your choice. You want to make a reference node as ground or VDD, anyone you can select your wish which one. Here I make a ground, and this is the name of power net is VDD and ground net is GND. Okay, and remaining same, there is no need to change anything, and run this one. Okay, here is so RCX is completed. So completion of everything. If you want to know what is layout, just go to here, go to NAND. This one here, the LVS structure is created, so just click on it to appear this one fit. And so here if you want to show classical view, basic view, your choice. Okay, just zoom it, shift F, so it show the device also. Okay, this one is control E, control F, it show the name only, and zoom it. So when zoom it, it show the register, capacitor, every component showing here. This one show register, capacitors. Okay, so this is extracted form of layout, so it show the internal resistors, resistance and capacitance. So okay, when okay, here I want to show another thing. You make any name here, so when you run this one again, you want to know any name, just name any name, just like this we extracted, we make just like NAND. So you make NAND RCX, so make a file name of name NAND RCX. We select this one, we extracted here. Actually there are too many files, this one, so by default I am using a we extracted, so do this one. Output file is a extracted form. Otherwise if you want to form a spectre, just click on it, this one name, so this name will created. If you want to use this file in different form or different tools, we can create this spectre. Otherwise if you want to show, this will show. Okay, so when you do it will go on, so it is better to again start. By default is this one. Okay, firstly we make this, set this file. Before do we have to again run LVS, otherwise show error. So for the simple just run LVS and then run RCX. Without a run LVS we cannot do perform sorry, before completion of LVS you cannot do RCX, otherwise show error. So firstly we have to clean LVS, then after perform LVS. Okay, so this completion of layout and physical verification of NAND gate layout. So this is complete schematic design and layout design and symbol creation of NAND gate. Okay, so here I am using Assura as a physical verification tool, and for designing we use Cadence Gpdk file. Okay, so thank you for watching my video. If any query related to Assura tools or Gpdk file of Cadence, or setup of Assura, or any problem related to Assura or different tools, you can comment on my this video. Okay, thank you for watching my videos.